So the question that we were looking at was, how should we cope after a big nuclear accident has actually happened? One of the worst, these are as bad as it gets as far as nuclear is concerned. Is mass relocation and abandoning of homes, is that the best strategy? It's been used in now 2 big nuclear accidents that have happened in the world. And then more generally, the research question was, how should we respond after a big nuclear accident has actually occurred? The NREFS project, which the Dean has described there, 4 universities and continued here at Bristol. I think it may not perhaps be a surprise that once one has actually finished doing the actual research, translating that into the final set of research papers is never a trivial, nor often a very short task, but that has now been completed and we have publication of that, of those papers, of 10 papers which are there in Process Safety, Environmental Protection, a special issue of that journal. The feature of the NREFS project was it decided to attempt to apply mathematical tools, and it was clear from what had gone before that what was needed was something to help alleviate the fog and confusion that naturally occurs after a big nuclear accident. Another feature was that we actually used in the NREF study, we used 3 independent mathematical methods. The J value, J for judgment, and I will say a bit more about that in a moment. I will describe each one to a certain extent. The J value assessment, and we applied that to Chernobyl, these 2 big nuclear accidents, to Chernobyl and Fukushima on a retrospective basis, that if we knew now what we knew, if we knew then what we know now, what would we do? Would we still do those things that were actually done? And then optimal economic control, which actually included health effects, were applied to hundreds of conceivable nuclear accidents all over the world. That was work that was led by Manchester University. And then we applied the codes that had been developed by Public Health England for looking at consequences of nuclear accidents and the costs associated with those consequences. And we applied that to a big nuclear accident assumed to occur on a UK reactor located in a fictional site halfway between Southampton and London. And that was led by the Open University. So what are the policy options? First of all, temporary evacuation, but this is really something which is quite short term, where you might move people out on a precautionary basis, but you would get them back within days, or at least certainly a week or 2. Then, moving on, relocation, which is what's happened before, and people have been asked to abandon their homes either forever or at least for a very long time, with all the consequences that brings about. If you can imagine you've been away from home for 5 years, how much do you really want to move back to that? So relocation, food bans, temporary or long-lasting, or even in the limit permanent, and then remediation. So this is cleaning up, urban decontamination, agricultural decontamination. To talk about the first method, the judgment or J value, what we're looking to do there is balance the life expectancy that a safety measure brings with it against the cost of providing that safety measure. And it's that balance that enables us to say that if the J value, we take J as being the ratio of what you are spending or what you're considering spending, divided by the maximum that you ought to be spending, and that tells you that if J is greater than 1, you're spending too much. And the unique feature of this is that it is entirely objective. There is no opinion involved in it. It's based on data from millions of people, both actuarial data, life statistics, life tables, and also on millions of people and economics. So it's economic and actuarial data, and it is completely objective. That is to say that any team around the world could use that same method and they would come up with the same answers. One of the things that we did during the development of this was to actually validate the J value against pan-national data. And what we were able to do was to explain the Preston curve. Preston curve, Samuel Preston in 1975 pointed out that GDP per head has a huge influence on how long people live at birth. And that's the graph for 180 countries in the UN, 193 in the UN, and that graphs the life expectancy at birth. And we were able to explain that, and we were able to explain 80% of the variation between countries, which is a pretty high figure for any social science study, which this effectively is in this instance. Well, we did that for 162 out of 193, and 60% if we actually looked at the full set of on which we had data, 180. And what we found was that the J value emerges as a formalization. It's what people do, basically. It describes how people take their decisions on safety in all countries, in all areas of the world, taking into account the resources they have available. That is to say that if we were in any other country in the world, we would act pretty much as those people act, and we would take the decisions that those people take. I'm going to mention some figures on life expectancy because I'm going to talk quite a lot about life expectancy, so it's a good idea to put something concrete down. The life expectancy at birth in the UK is around about 81 years. Excuse me. 42 years is the population average. So if we actually take how long is everyone going to last from now? If we looked at the whole nation, we'd say, well, people are going to live on average 42 years before they die. It's average across all ages. Now let's come down to some particulars here, and this one was something which always upset my colleagues at Manchester. It just happened to be so. I happened to be working in London. They were working in Manchester. 3.25 years lost by someone who moves from North London, in Harrow in North London, to Manchester. That's the average person. And it's 6.5 years if you do it at birth. And then 4.5 months is what the Londoner, by contrast, loses to London's air pollution. And that's on average across the population. It's 9 months at birth. Now let's look at to put things in context, let's look at some losses of life expectancy after the Chernobyl reactor accident. Well, we in this country, looking at the standard way of calculating the harm caused by radiation, we lost just under 3 hours of life expectancy in this country because we had some fallout in this country. The 116,000 people who moved away, how much life expectancy did they lose? Less than 10 days. But that's not the question. The question is, what would have happened to them if they had actually stayed in position? Those 116,000 making up the first relocation. Well, 85,000 of those people would have lost, on average, just 3 months life expectancy. So if the world's worst nuclear reactor, 85,000 of the people in that first evacuation would have only lost 3 months life expectancy. That's only 2/3 of the figure that people in London are losing as I speak. 31,000 would have lost more than 9 months life expectancy, and according to our method, the J value, we would say they ought to move out. It is worth it for them. And if we actually stipulated that whole villages or towns, settlements, needed to be relocated, if 5% of those people needed to be relocated, that is to say their loss of life expectancy was 9 months or more, then the figure would rise to 72,000. But that's still quite a lot less than 116,000. Now let's move on to the second mass relocation after Chernobyl. Now 220,000 people were relocated. This is 4 years later. Why did they do this? Well, 220,000 people were relocated after 1990. If we look at the most highly exposed 1,000 of those, they would have lost less than 3 months life expectancy. So, not surprisingly, the J value recommends that you shouldn't have moved any of those people. So in total, 80% of the people who moved after Chernobyl accident should not have been, according to the J value. That's a city the size of Derby should not have been moved. Now let's have a look at Fukushima Daiichi. Well, Fukushima Daiichi was by no means as serious an accident as the calamitous accident that happened at Chernobyl. The worst affected people there were inhabitants of a small town called Tomioka, and they faced the highest radiation dose in year 1. But it was only 51 millisieverts over the whole of that year. And that will have fallen to the safe return dose, which is what the Japanese government has stipulated, 20 millisieverts per year after about 6 years. That's about now. Some of the villages started off with less dose than the 20 millisieverts per year safe dose. One of those is Naharaha town, but you see there that people moved out and very few have moved back. So what was the benefit of moving out? For people in Tomioka, who were the most exposed, then they would have gained somewhat less than 3 months life expectancy by relocating for 6 years. And if they then, over and having come back, they would then lose a further 2 or 3 months from the living under the safe relocation dose. One of the things about this is that the dose is falling away at all times, and that's what the graph on the inset graph on that shows you. That if you get, it's 51 millisieverts in year 1, but it's falling away very rapidly and is a lot lower by year 5 and year 10 and so on. So was it worth it? No. As far as the J value is concerned, it's difficult to justify relocating any of those 160,000 people who are relocated after Fukushima, the accident at Fukushima Daiichi. That's what the J value recommends, and to put it in context for intuitive purposes, we're talking about less than 2/3 of the air pollution toll on Londoners. And if you think that J value is actually encouraging people to take risks, I can tell you that it values life much higher, much higher than the UK government's value of a prevented fatality, which is the standard method for cost-benefit analyses in the UK. That has its own problems which have been pointed out, and it is, but in addition to that, even if we put those problems to one side, this the J value values life a lot higher. So these are not soft recommendations. When it comes to urban remediation, then the things that are being done are quite sensible. So the decontamination of 110,000 houses in Fukushima City, that was a good idea. It cost $370 million, but it's good value for money. The agricultural remediation, here again, and these even 20 years after the accident, then agricultural remediation like adding ferrocin to cattle feed to reduce the uptake of radioactive cesium, which is the principal component that is the problem, replacement of contaminated soil, and then ploughing, liming, and so on, again looking to substitute to displace radioactive elements with similar elements, chemically similar and stable elements. But they're a good idea. Food bans, we ourselves, how did we fare after Chernobyl? How did we do? We actually looked at these. Obviously, there were a number of things we could look at. There was a huge number of things we could look at, but we were restricted in the amount of time we had. But we did look at the UK response on land restrictions. The problem with that was that it took 26 years to lift the restrictions. And so banning lamb from certain pastures from entering the food chain, it took 26 years before they were removed. And by that stage, they were saving 8 seconds of life for the UK citizen, which is not very high, I think you will agree. An extreme consumer who eats loads of contaminated sheep meat, only contaminated sheep meat basically, and he'd lose 2.5 hours of life expectancy. So the sheep meat restriction should have been lifted earlier. I want to throw this one in to give some indication, because I've talked about loss of life expectancy, and I've talked about it across a population, which is an average across a population. But what happens to those poor people who actually die as a result of the radiation that they get? They die as a result of a radiation cancer. What age do they die at? Well, the blue line shows their average age at death. And you can see from that they will tend to live into their 60s, and they have a 2-to-1 chance of living longer than about 50. So that's a further thing for you to think about. And then the loss of life expectancy for a radiation cancer victim is between 8 and 22 years. What that means is that on average, the radiation cancer victim will lose half or less than half the life expectancy he or she would lose in a fatal accident, such as a rail crash or a car crash. So there's a certain amount of gallows humor, perhaps you might think, in the last sentence there, but if you did have a choice, it's an unrealistic choice, but if you did have a choice, then radioactive fallout every time.